Hello, and welcome to this MCMA webinar, The Intelligent Factory Using Smart Components and Connectivity to Help Cut Costs and Improve Performance. My name is Joanna Keel, and I'm the Manager of Marketing and Membership for the MCMA, and I will be serving as your moderator today. Attendees that have joined this webinar have joined in listen-only mode, which means that you are muted. If you do have a question during this webinar, please submit them in the questions panel of your webinar screen, and we will answer all questions via email after the webinar has concluded. This webinar will be recorded and a link will be sent to you within the next 24 hours. And now I'd like to introduce our presenter for today's webinar, Kristen Mawatsky. Kristen is a contributing editor for Motion Control Online and has written about motion control and automation for more than 7 years. As a technical writer, she covers a variety of subjects ranging from memory and microelectronics to nanotechnology to lasers and photonics. Kristen previously worked as an engineer on NASA's Chandra X-ray telescope before switching to writing about technology. Kristen holds a Bachelor of Science degree in physics and a master's in optics and photonics from the University of Central Florida. And now I'd like to hand it over to Kristen to get started.
Oh, thanks, Joanna. Thanks everybody for coming, and yeah, let's talk about the intelligent factory. So there's been a lot of discussion. I'm sure, unless you've been a hermit in the middle of the woods somewhere, you've heard all about the Internet of Things and the industrial Internet of Things, and the whole move towards smart components, etc. What I think has been particularly interesting over the past year is we're starting to move out of the let's all talk about it speculatively and hey, we've got these smart components and we know how to connect things, so maybe one of these days we can make this all work. And now you're getting companies that are doing it. There are certainly the motion control vendors are in kind of a unique spot in that they make the components and they use their components to make their components. And several of them have begun fielding these kinds of systems for developing, an intelligent factory top to bottom, because they built them for their own factories in order to be able to view what's going on. So kind of exciting times out there. It's not necessary to do complete greenfield. You can do retrofits and so on, but there are definitely some benefits to be had. So let's get started here. Probably no surprise to anybody out there who's an end user. It's a pretty competitive marketplace out there right now. You need the flexibility. You need to do more with less. You need to know what your assets are doing. You need to cut out waste. And in particular, what's hard these days is you've got organizations with multiple locations, multiple factories, and they're trying to keep track of operations at all these places and optimize performance. You want to minimize power consumption and downtime. You want to make the greatest amount of product that you can. So that's where factory visibility is sort of the holy grail. If you are one of these organizations, even a small organization really, but if you want to be able to take a look and see what is happening machine to machine, take a look at how production goes line to line, plant to plant, even shift to shift, that can, number one, bring you a lot of insights, and number two, help you increase performance and output, because if you've got one shift that is consistently producing more product, what you want to do is be able to find out why the two don't match. What's going on? Is it something that you can make a change with? Is it something that is a factor of the equipment? Is it the way it's laid out? Is it that your personnel maybe isn't trained to work optimally? What exactly is going on? And you've got to have that data. If you don't have the right tools, you're not going to be able to find the root cause of the problem, and that's the whole motivation. behind doing this factory visibility. And as I mentioned earlier, industrial Internet of Things. It's funny, the talk has been on and on about IoT in the consumer space and smart thermostats, refrigerators that can order you milk. But in the industrial space, the upside is just enormous. And in some ways, we've already got pieces of this in place. You've got smart components have been out there for, 10, 15 years. You've got embedded sensors. You've got shop floor to top floor communications in a lot of cases. So the goal is to push for greater transparency up and down the food chain. Now they are talking about the industrial Internet of Things representing 5.4 billion devices shipped annually for a 48.2 billion installed base. And again, the benefits that that's expected to bring in terms of streamlining factory automation is supposed to be pretty prodigious. And you can see here in the data plot, you can see the comparison with consumer IoT, which is the pale green. Again, the industrial is going to completely outweigh it. And the connectivity, you can improve efficiency, you can minimize downtime, shrink lead time, which means you're reducing inventory. You can also do a better job of personalizing your items, and increasingly consumers and customers are getting accustomed to having that. That's what they want. So this promises an easier way of doing it. And before we go too much more into the conversation, just for the whole common language thing, overall equipment effectiveness, and that takes us back to the conversation we were just having about comparing machine to machine, line to line, plant to plant. You've got to have metrics, and OEE is a good one because what it comes down to is how often is your machine making stuff, how well does it make it, how efficiently, and how much of what you make is saleable. So again, that's where the factory visibility is designed around giving you the information to make sure you're maximizing OEE, that you're making sure that if there are problems that are going to create a problem, going to create downtime or whatever, you know about it ahead of time, because you not only have the smart components and sensors in place to track whether a component is wearing or whether you're suddenly drawing a lot more current or energy, but you've got the analytics and the software in place to send the information regarding that to the people who need to know. And that means sending it to your maintenance people. That means also sending it to management and maybe even to the operator, so that they're in a position to do something about it, depending on how the information that you've got available to them and kind of the latitude. So let's take a look at a case study of what this kind of visibility can do. Jimmy Dean sausage, raise your hand if you've ever had it. Apparently the 1-pound packages of Jimmy Dean sausage are like one of the top selling sausages, certainly in the United States, if not elsewhere. 150 million pounds of those bad boys get made every year. And the HILLSHIRE Farms factory had 11 machines producing this in the 1-pound packages. The issue that they started running into, though, or they realized they had, is the packages weren't getting filled consistently. It's supposed to be a pound. From a regulatory standpoint, it better be a pound, or else you're going to wind up getting, number one, in trouble for fraud from the weights and measures people. And also you've got angry customers and so on. So they definitely want to make sure they're not underweight, but if they're overfilled, then you're giving away product. And it doesn't, with the kind of volumes we're talking about, it doesn't take much overweight to actually make a pretty significant difference in the bottom line. Now, they had a system that was, pretty much pass fail. If a package was underweight, they would know, and that was about all the visibility they had. And they wanted to get better control of the loss. So they wound up going for an intelligent solution. They did an integrated control architecture across the organization. They used Ethernet IP connectivity so that they were able to monitor what was happening on all those 11 machines. They had analytic tools to make sense of all the data and look at historical trends. And what they wound up with is much more comprehensive data. Now they could see where the problems were cropping up, which machines were producing over and underweight packages. The operator can find out immediately. They can easily access historical data performance. Dashboards make it easy to access the information they needed. And they were able to target problems and take care of them in a timely fashion. Now, they got some really impressive results from this. The data they were able to capture was the weight of each package, each batch, and each shipment. And that resulted in 0.1% yield improvement within 6 weeks of installation, not installation, excuse me. My voice software attacks again. 0.1% doesn't necessarily sound all that large until you compare it back to that baseline number we were talking about earlier. And 0.1% of 150 million is a heck of a lot of sausage. Estimate is savings of about 105,000 pounds annually, which runs in the neighborhood of hundreds of thousands of dollars in savings. Now, that was after 6 weeks. Their estimate is that they will probably be able to realize almost 0.5% of savings. They expect ROI within a year. And again, that's just from having that level of transparency. Energy management, now that's another one that if you've attended any of the IoT or productivity, you probably heard me yap about this before, but energy management is a pretty important and huge cost-saving area. I mean, look at this number from the US DOE, $2.4 billion in the last 5 years alone, just using energy management techniques. And by the way, servo fun fact, 25% of the operating cost of a servo is energy. It's just power. So again, if we can get better control on what's running when and do it wisely, there's a good opportunity for cost control on the end user side. And that means that that's something that OEMs and machine builders should be thinking about integrating into their system. So it's just a quick and dirty on power payment or energy billing. You've got a number of things that you care about. There's the consumption, total amount of power consumption that you use. But then there's another charge, the peak demand usage. That has to do with your peak energy draw, and that's scaled by the demand of the previous month or quarter, depending on the utility. And that's because if you're drawing really hard, they've got to have larger transformers and conductors and everything else in order to support the higher voltage. So that's why they charge it that way. So if you're able to lower your peak demand, then your overall energy fees are going to drop. And in particular, the bottom factoid, 30% of your energy bills are peak demand charges. If you don't believe that, let's look at a quick table here. And if you've got two companies that consume the same amount, same demand rate, same electricity rate, but because one has so much higher peak demand, they pay a significant amount. Now that's a monthly charge that adds up really quickly to over $1 million for something that you could potentially manage your way around. So that's why people are really paying attention to this. Energy monitoring has gotten pretty common. There are a number of vendors out there now, even those who aren't doing comprehensive factory visibility solutions do have energy management offerings that rather than kind of doing a bolt-on, network together some meters and get a developer to write some software for you, you can go ahead and buy these things. And they're much more effective. There's not the learning curve. There's not the time delay. And it comes back to that word that really is important in this context, which is that it's consumable. You want to make sure that when you're investing in these systems, that you're getting data that you can work with, that's coming to you rapidly, and that you're able to convert it into something that you can use to make decisions. I've been wearing one of my other hats, do a lot of writing about business analytics and data warehousing and so on, and that's always kind of the catchphrase there, is how can you turn data into actionable information? Because you can have all the data in the world. If you can't do something with it, if you can't quickly look at it and make a decision to take care of a problem in the making, then it's really pretty useless to you. I had some data plots on here, but it looks like they are not showing up. Anyway, this is a company called Agri-Fab, and they make lawn care equipment, and were looking to cut their energy charges. So they went with a solution of networked metering devices, analytical software, and a dashboard. I would be showing you a nice, tasty little plot comparing, but you won't see that. But the low-hanging fruit was that they had annual savings right off the bat. They discovered that their ovens weren't set properly, so after hours they were firing, and right off the bat they saved enough that they would add up to $70K. They also found an issue with air compressors, and the funny part is they got back to the vendor at the time saying, oh, I think there's a problem with the system you sent, and that was when they discovered that no, there was an issue with the air compressors that nobody had expected. They wouldn't have seen it without the monitoring. So the monitoring solutions and, again, having the consumable data, that's really the key. So what you're really looking for is connectivity here. That's kind of the issue. How do you connect everything? How do you make it consumable? And most of all, though, you've got to have a plan coming in. And I'm going to keep harping on that because back, I don't know, 15 years ago, 20 years ago, when ERP first came in and everybody was really hot to get ERP systems and get connected, yay, there were more than a couple of government agencies and large organizations that I covered that spent tens of millions of dollars on ERP systems, SAP, the whole 9 yards, big iron platform. And a year later, they were still not able to get them up and running. I have a friend who helps, she's an architect who helps put together these kinds of systems. It typically takes 6 months to get them running on occasion. So one of the things that kind of runs through my head when I start hearing about all of these factory visibility systems and so on is, it's all well and good, you go buy this stuff, but are you able to speed the time to value? Are you able to put it in place and do it efficiently so that you're able to pull that information off, render it into a consumable form that you can use to make business decisions with? and not just analytical, kind of long-term batch processing, yay, let's plan for the year ahead, but real time, there's a problem with the line, what do I do now? Those kinds of decisions. That's really the test of this kind of equipment, is whether you can get that out. So really, kind of the advice is don't just grab data. It can be really tempting. Yay, I've got all these sensors all over my equipment, so I'm just going to have myself a time. Don't squander your efforts. Pick a pain point. Pick a risk that you want to mitigate. Come up with something very concrete. Decide on the exact question that you want to ask, and then find out the data that's going to answer that question, and make sure that your system's in a position to analyze it and come up with information, and also that you've got some kind of a dashboard or way to present it so that you can make use of it. The thing to keep in mind, data has a cost. You've got to have somebody managing it. You've got to have storage. You've got to spend time routing it around your network and so on. The other thing that can be challenging in the industrial environment is that you've got a lot of data coming through on sensors. You may not even need all of the data. That, let's not just find a needle in a haystack. Let's try to grab that needle out of the hay flying by, because if you've got 20 sensors on the oven that's running for 5 hours or whatever, and they're taking constant data, you don't really need or want to store all of that information for batch processing. You want to watch it right now, so if there's something going wrong and you need to take action. Otherwise, it's useless. So you might as well try to find a way where you can just winnow through and get the information you need. But again, with this whole planning thing, it's really one of the most essential aspects. You've got to know who's going to use it, who's owning it, who's responsible for it. Otherwise, you're just going to be drowning. So the next thing is you've got to take a look at where your equipment, what your system looks like. What do you need now that you know what you want to do? What do you need to accomplish that? Do you trust the data that you've got? Does it have integrity? What's the architecture in terms of your storage, in terms of also sending it around? Now, it's not necessarily going to be a situation where you've got to go greenfield with this. You can potentially go ahead and kind of backfill to take you from where you're at to where you need to go. Again, if you start small, you can always spread out. When you get a couple of successes, you can kind of implement things more broadly. Now, let's look at an example in terms of this whole idea about where the data goes. I mean, imagine you've got a bakery and you've got a muffin coming off the line, and the data comes back and shows you, hey, you've got increasing waste. So that can be multiple options potentially. You're going to be sending messages to quality control, but inventory management might need to have that because you need more raw materials. Maintenance or your control engineering team might need to be coming in and looking at what's going on with the oven. I was just doing some research the other day on cake frosting lines and the number of servo motors that are involved in automatically making these fancy cakes. If they go south, you need to not only let people know that, hey, the numbers are going to drop down, you're not going to make your production, but you've also got to get maintenance out there fixing. So the whole question is, how are you, does your system go ahead and send the data to the right people so that they can make decisions? that they need to. One of the advantages of this level of transparency is it's kind of another case study sort of thing. You can really do item by item batch processing. So you're not just doing large amounts, as we were talking about back with the HILLSHIRE farm example. You can track a batch size of 1. You can follow raw materials all the way through the supply chain out to the customer. You can trace each component and device. If there's a problem in terms of quality control, you can get back through the system and know exactly which items are the problems, which ones you have to pull off, which ones you have to rework. Particularly important for medical, automotive, pharmaceutical. I was talking with someone at an end user the other day. They have their employees barcoded so that when they go to load something in, load in a part, they swipe their barcode so that they know exactly who did it, what happened, how it worked out. Another example is a torque gun used, an automated torque wrench used in automotive manufacturing. Now that's not your standard smart component, but they've actually sensorized those and networked them together so that now during assembly of a car, they can go in, tighten a bolt, and the system takes a reading off of the torque gun and sends it to the database where it's stored under the VIN number for the vehicle, so that they've got complete traceability. If they ever need to come back for accident forensics or anything like that, they'll have a complete and full record. And again, that's what comes from being able to run these kinds of systems. Now, we need to talk about some of the logistics of actually doing it. You've got to obviously have network infrastructure because you're going to have a lot of data whizzing around. And part of the question is, how do you manage all of that data? And it's got to happen in a couple of ways. You've got to get, first of all, harvest the data from the components. Now, most PLCs have data logging capabilities these days, depending on the components you're working with. And a lot of this comes back to the application. Again, what is the scale of that problem that you've decided you wanted to fix? How much data are you measuring? How many sort of physical data points? How frequently? What's going to be the overall volume? Now, if it's fairly low, there are HMIs that have data logging capabilities. It may be enough to do the data logging functions that are part of your PLC. It may be, if you're looking at really high volume and you want to be dumping it over regularly, that you need to go ahead and get a dedicated data logger. So that's really kind of where the planning ahead really needs to start from the very beginning. And all of this stuff is out there now. It's available, and there are a few organizations who are in a position to be able to field integrated systems and assist with kind of the whole planning and organization and everything else. Oh, now they backed up. And of course, that also brings us to the whole question of connectivity. The connectivity angle, at this point in time, most organizations are really on board with shop floor to top floor connectivity. So you've got information going from the machine networks potentially up to the ERP system. But those really tend to focus on more of your batch analytics, kind of overall big picture system planning and trends and that sort of thing, and not really the day-to-day nuts and bolts that you need to keep the plant running and really understand what's happening out there. You're going to get more of that kind of functionality going through MES systems, manufacturing execution systems. So the big push is figuring out how to get data from your machine network and your sensors and so on up to that. Now, kind of the standard way to do that for a long time has been to use a gateway PC, and that can certainly do a very effective job. They're good at pushing a lot of data around and then doing processing on it. The challenge that you can run into is there's sort of the interface between IT and the plant floor and engineering folks, where the IT people don't really want to let too much slip about the enterprise system security and so on. But on the plant floor, if something gets screwed up and somebody inadvertently rewrites code, you could have mayhem going on. So there's traditionally been a little bit of crunchiness there. It's not as easy as it could be. Another challenge there too can be, in general, computing platforms are constantly in a state of flux. You've got upgrades, you've got hardware upgrades, you've got operating system upgrades, you've got fixes going in and so on. So there's certainly a chance of needing to rewrite code and so on. That's going to be mitigated to some extent if you're working with open standards. That's going to be easier. There's going to be less proprietary work to do. But we're also looking at another one of these things coming up where it's depending on your application. There's another option that's starting to be available, which is an MES appliance. Those of you not in the know, appliance basically just refers to a box that's dedicated to kind of doing that one job. And these MES appliances are kind of considered to be the bridge between the IT and operations to just get that data off the shop floor and into the MES system. They can do a certain amount of processing. That's where you get some, they call it edge processing, so that to a certain extent the data is already rendered in a somewhat consumable form. And that kind of goes back to that discussion we were having earlier, again, of what do you do to just being able to harvest the data off of your hardware is not enough. How do you take that and turn it into intelligence that's going to flag you when there are issues and going to facilitate either making those comparisons among equipment or knowing when you've got a problem that you want to address. So those appliances can be really helpful for that. Security definitely continues to be an issue. So something to keep in mind when you're doing your planning. You want an interface, again, that is going to easily display information. You want dashboards that are accessible. Now, ideally, and again, this is where things like these appliances can be helpful. If you want to have specialized dashboard screens, there certainly is room to have people do that, but there are increasingly kind of quick start systems out there that will do that heavy lifting for you so that you've got something that you can get started with right out of the gate. Again, speeding up the time to value, and that's something that will certainly help with adoption more broadly in the system. the system and the organization. So kind of the route to success is really you want to, as we said, identify the problem that you're trying to solve. You want to establish your project scope, plan your backbone, make sure that you've got the infrastructure in place, make sure that you've got the security in place that you need everything to be supported by. You got to create a data strategy, and most of all, you've got to find a way to convert that data into actionable information. What is it going to give you? What is it going to tell you? What's going to make it consumable? And then the next thing is, how do you get it in the hands of the people who are going to be in a position to use it? And you may find one of the people I was talking with in conjunction with this project, they said that in general it's that low-hanging fruit, as one of them said, it's constantly going to regrow. It's like that Agri-Pro thing. They thought they had one low-hanging fruit with the oven, and then they had another with the compressors. And there are going to be increasing numbers of questions once you start solving some of these problems. At this point, everybody pretty much agrees this is all still very much in the early adopter phase. There's a lot of companies that are still sort of standing back. There are organizations out there still using Excel spreadsheets and so on. Again, you start small. It's not going to be a massive investment. In fact, one of the sources they spoke with for this mentioned that there's really kind of a constant level of surprise on the IT side, and this was with respect to one of these MES appliances, when they hear about the price tag, because they're used to, again, $10 million ERP system, and all of a sudden they're looking at something that's significantly less. So it might be more appealing than you might think, if you're one of the people that's still out there with the spreadsheets and so on. But the thing that comes to mind to me whenever I see numbers and information like this is really that it's an opportunity to gain a competitive advantage, because in this day and age, things are so competitive and customers are only going to get more demanding. Margins are going to get tighter and tighter. This is a way to get more from your equipment and more from your operations. I was talking with a machine builder at one point, and they said that they had gone to a customer's facility because the customer was saying, we've got to get another line. We can't produce enough, and we're not making our numbers, so we got to do something about that. And they ran an audit on the machine and discovered that the machine was actually only working at about 75% of design spec. So they didn't actually need to get a new machine. What they needed to do was tune up the old one and make sure that it was operating up to spec. So, that's the thing that this can bring to you. One of the aspects of this that I started to talk about, and then I yanked the slides out because it's been hit over and over, but is the amount of benefit that this level of transparency can bring simply to operations and maintenance and so on. Because you really can use it to go from preventative maintenance to predictive maintenance. There was the day when it was, it's going to break down. I'll fix it. That was breakdown, and then we'll replace it ahead of time. And then you started doing we'll look at our models, and we'll get that batch processing in our ERP system and try to figure out how long these things last in general. But again, when you've got these drives that are able to monitor current draw, or even when you've got the energy audit capabilities, and you know what your baseline energy consumption is, for a machine, and all of a sudden it goes shooting up. And maybe it's not the oven's being left on, or the compressor, um, or a motor being left running on a compressor. Maybe it is a function of wear. So if you're doing the energy auditing, all of a sudden you're going to find out about that. Or if you've got your drive, seeing more current draw or something. The point is, you've got, not only do you have a baseline that really informs you the health of these devices, but you've also got the ongoing information about their performance on a moment-by-moment basis. And that is going to be what helps you get in there ahead of time before you got downtime that's unexpected, and let you kind of keep things running. Now, I just finished up an article on this for the MCMA website, and one of the examples they threw in there, since they seem to have baked goods on the brain these days, is that whole idea of having a problem with the cake frosting motors. You've got the servo motors that are going to be spinning the little pedestals for the cakes and spinning the gizmos on top that squish out the frosting. Well, if you've got a massive order for a giant box store, and all of a sudden your line goes down, and maybe because you've got the transparency, you're able to know that that's coming ahead. So in the old system, bang, it would have been a surprise. You would be down for several hours, and if it's for a holiday order, that can be a big problem. Visibility brings you a couple of things. Visibility lets you look and say, okay, I know I got some kind of a problem coming up, and I can see that I've got some anomalies showing up. I also am able to see that I've got increasing scrap. So the system is going to send a message to maintenance so that they can come down and take a look. It's also going to send something to the plant manager so that they know what's going on, and they're also in a position to be able to reach out or check their other facilities, elsewhere across the country, to see whether they've got the ability to backfill. If the system, despite all the intelligence, if the actual problem is large enough that they're going to lose a significant amount of production, then you can, SNAP be able to say, look, here's how much we're going to be down. Can you guys step in and take care of it? They can use the factory transparency or visibility to be able to look at their inventory and what they've got coming on for scheduling and say, hey, yeah, we can do it, and rapidly make the change. There's a level of nimbleness there with organizations that it just wasn't feasible before without this degree of intelligence. And it's here. We've got the capabilities. In many cases, the machinery that's on the floor that has the smart drives and fairly recent PLCs. It's really that level of connectivity that you need to put in place. If you've got the connectivity there, then it's a matter of having the analytical software and kind of go to town. So anyway, interesting stuff going on. It really, my sense based on the people I'm talking to, is this is really in a position to break wide open over the next year. Just looking at the number of companies that are doing it and the success stories that you're starting to hear about. So it's worth looking into. It's worth talking to your vendor, because in some cases they're way ahead of you. They've already got the system put together because they've been using them in their factories. So work with them and ask about some of these technologies that we've been discussing, because there are some really interesting tools out there to kind of get some competitive advantages. Anyway, that's about all I got. Appreciate you taking the time to listen.
Yeah, thank you, Kristen, for that informative webinar. And again, thank you to all of our participants today. If you did have any questions for Kristen that wasn't addressed during the webinar, please feel free to type them into your questions panel on your webinar screen, and we will answer those via email after this webinar. As a reminder, this webinar has been recorded, and an email with a link to the recording will be sent to you within the next 24 hours. And also be sure to check out www.motioncontrolonline.org for a list of all of our upcoming webinars. Thank you again, and have a great rest of your day.